Okay, hello my dears. Today we're going to do graphing some linear inequalities. Again, a solution set of two variable linear inequalities. So just a couple quick key ideas to remind us. When we are graphing inequalities, when we're looking at the inequality symbols, the greater than or less than symbols, right? If it is just greater than or less than, so there is no equal to sign underneath, this means you're going to be graphing a dashed line. If there is an equal to sign underneath your symbol, then that means you're going to create a solid line, and that means all the points on that line are included in the solution, whereas with that dashed line, that means they are not included in the solution. And then my final answer is going to be where my two where my two areas intersect each other. So the solution is that shaded region where they're going to cross over each other. Again, just a little reminder, dashed line solution does not include the points on the line. And if it's a solid line, the solution does include the points on the line. Okay. So here's my first example. It says, graph the following system of inequalities on the coordinate grid. So I've got two different equations here, and what I want to do is make sure that both equations are in slope-intercept form, right? So slope-intercept form, again, is y equals mx plus b, where m is my slope and b is my y-intercept. Can't graph unless it's in this form. So notice that for both of the equations that I have here, they're in standard form. So I'm going to have to rewrite both of them. So let's start with this one on top. I'm going to do this one in green. I also want you to notice I've just got a greater than symbol. So this already tells me that when I go to graph this line, this is going to be a dashed line. And my answers are not included because there's no equal to sign. So I'm just going to rewrite this equation. And then we're going to rewrite it so that the y is all by itself on the left side of my equation. So first thing I'm going to do is I'm going to move this x variable from the left to the right side of my inequality symbol. So this is a positive x, so the inverse operation of a positive 1x would be to subtract the 1x from both sides. My x's will cancel. I'm left with negative y is greater than, and now 5 minus x, I can't combine those together. Those are not like terms, but I want to write it in this form up here, the slope-intercept form. So I'm going to put the negative x first, and then I'm going to put the 5 afterwards. And this is a positive 5, so I put plus 5. Now, I'm almost done, but I still have a negative sign in front of the y. So what I need to do is get rid of that. Now, if there's no number there, you can always put a 1 as your coefficient. So to get rid of the negative 1 times y, I'm going to divide by negative 1. Whatever I do on one side of the equation, I have to do to the other, and I have to do to every part of the equation. Now, when you multiply or divide by a negative number, your sign flips or it changes. So instead of being greater than, this is now a less than symbol. Negative divided by negative with my x's is going to cancel. This is a positive x. A positive 5 divided by a negative 1 gives me a negative 5. So my first equation that I'm going to graph is going to be y is less than x minus 5. And so we're going to graph that one first. This negative 5 is my y-intercept. And my slope is whatever's in front of x. Now, there's nothing there, so my slope is really 1 over 1 is my slope. Ooh. And again, the rise over run. So rise means I go up or down, and then run means I'm going right or left. So a positive 1 is going to take me up, and a positive 1 is also going to take me to the right. So I'm going to start at negative 5 on my graph on the y-axis. And then my slope is I go up 1 to the right 1, up 1 to the right 1, up one to the right one. And then I can reverse it by going down one to the left, down one to the left one, until I've got myself a line. Now, again, this line has to be dashed, remember, because it does not have an equal to sign with the inequality. What is happening with this pen? It is not working. Come on. Okay. My dashed line. Okay, and now I've got this is now a less than symbol, so I need to shade in everything that is less than all the numbers that are less than where my line is on my graph. So if I'm looking at my graph, greater than would be obviously above this green line, less than would be below. So I would shade this entire bottom piece here. Okay, that is one of my inequalities. Now I have to do the other one. So switch colors. Oogie. And now we're going to look at this equation down here. Now, I see before I rewrite it that there is an equal to sign. So this already tells me this is a solid line when I go to actually draw it. So I want the y's to be all by themselves. Whoa, come on. You know, you think this thing will work? Okay, so I'm going to move the 2x from the left side over to the right by doing the inverse operation. So I'm going to subtract 2x from both sides. I'm left with 3y is less than or equal to, and now again, we can't put a 12 and a negative 2x together, so I just rewrite minus 2x, and this is a positive 12. Okay, now want to get the y by itself, so in order to do that, inverse operation, opposite of multiplying by 3 is dividing by 3, and again, I have to do it to every part of this equation. So I am left with y is, actually I'm going to do it below. Y is less than or equal to, so negative 2 over 3x, I'm just going to leave. We actually like fractions in this moment because it's good for my slope. A positive 12 divided by 3 gives me a positive 4. Notice that we did not switch our inequality symbol because we weren't dividing or multiplying by a negative. So this is now my second equation I'm going to graph. My y-intercept is a positive 4, and my slope is negative 2 over 3, which is going to take me, negative 2 over 3 takes me down 2, and 3 is positive, so to the right 3. So I start at positive 4, and I go down 2 to the right 3, and do what? Down 2 to the right 3, 1, 2, 3. Okay, so on and so forth. And now, again, making this a solid line. Okay. Beautiful. Now, this is a less than or equal to symbol. So again, I need to shade in everything that is smaller than the values here of where my line is at. So again, above the orange is going to give me positive numbers. Below the orange is going to give me my negative. So it's everything that is below this orange line is my solution. Now, your final solution, though, is where your two graphs, the solutions intersect each other. So you can see in my picture where they actually intersect is this section right over here that I'm highlighting. So your final solution is only going to be values that are within this area. So actually everywhere else that I have shaded in, I'm going to get rid of because that is not where the solution is. The solution is only where they overlap. So my final answer, this would be my graph right here, my dashed line, my solid line, and then where the two intersect is my final answer. So any point that is within this highlighted section would be a potential answer. Okay, just one more. Example number 2. Use the graph to determine the number of solutions the system has. Then state whether the system of equations is consistent or inconsistent, and if it's independent or dependent. So I've got two different equations here. One of them you'll see already is written for me in slope-intercept form. Y equals x plus 4. Love that because I don't have to do anything with it. So there's one of my equations. My second equation, though, notice, is not in the correct form. So I am going to rewrite the second one to be in the correct form, which is slope-intercept, y equals mx plus b form. Okay, notice here, this is also a linear equation, not an inequality, because I've got an equal sign here. So I want the y by itself, so I'm going to move the x from the left to the right by subtracting. So I've got negative y equals negative x, and this is a positive 4, so plus 4. And again, still want to get rid of that negative sign in front of the y, so I'm going to divide by a negative 1. And whatever I do on one side of the equation, I have to do the other, and I have to do to every part of that equation. So I'm left with y equals, no, come on, negative and negative cancel out. I just get a positive x. Oops, I just realized I wrote something wrong. This was supposed to be minus. That's a negative. Okay, so negative divided by negative, these two will cancel out. I get plus 4. So hopefully what you notice about these two equations is, oh my gosh, they're exactly the same, which is fantastic, because if they are exactly the same, that means they overlap one another. And because they overlap, that means you have an infinite number of solutions, because your line goes on forever and ever and ever. So this is going to be infinitely many solutions. So I can already see with the choices that I'm given that B has to be the right answer, because that's the only one that gives me infinitely many solutions. But the other part of this is it consistent, inconsistent, or is it independent or dependent? So in order to be consistent, you have to have at least one solution. So consistent is one or more solutions. Now, because obviously I have infinitely many solutions, yes, it is definitely consistent. If it is inconsistent, that means it has no solution. And then the last part, independent or dependent, if it is independent, you've got only one solution, exactly. Okay, just one. If it's dependent, you have infinitely many solutions. Ooh, this is not working. Infinite solutions. So obviously, because our two lines are overlapping and they're exactly the same, I'm going to have a dependent system of equations. Okay, so those are your two examples. Go ahead, pause the video, and give your practice problems a try for AR.9.4. Okay, and if I can stop this video, that'd be great. Looky.